Hello and welcome to Solving Logarithmic Equations. Here I've written one. This is a logarithmic equation, and what makes it a logarithmic equation is that you can see we've got some logs in the equation here, and it is an equation because it has a left side equals a right side. And these logs, they're not just numbers. It's not just like log 10 or something. It's got a variable. So it's really involving the logarithmic function. And when you see that, you know you're dealing with a logarithmic equation. Now, how do we solve these things? Well, we're going to use our laws of logarithms to help us, and a few tricks here and there. First thing I'm going to do is I'm going to take this log here and combine it with this log on the right side. You see how they're both base 5? So why don't we do this? We'll keep this one on the left side and just leave it there. And what I'm going to do is add this whole other logarithm over. So I just do that. We're going to add it over to the other side. Okay. And so all that we have left on this right side is 1. Then I look at these two logs and I go, hey, they're both base 5, and I'm adding them together. Why don't I combine them into one logarithm? And I can combine them through multiplication. So I have x minus 6 and x minus 2 equals 1. Now at this stage of the game, the easiest thing to do is to switch it up and go out of this logarithmic form back into exponential form. Okay? In other words, I'm going to take this and say, well, this says 5 to the 1 has to equal all this stuff along here. Okay? So in other words, I can write it this way. 5 to the 1 equals all the stuff that I just underlined. So now I look at it and I go, hey, that's just an equation, and I can probably go ahead and solve it. So I'm going to work a little bit over here. I think I'm going to be short on space, so I'm going to work on the left side. 5 to the 1 is just 5, and now I'm going to expand out the brackets here. So I'm going to have x squared. Then I'll get a minus 2x and a minus 6x, which combines to make minus 8x, and then a plus 12. All right, so I see it's a quadratic equation. Probably the easiest way to solve it is first of all get 0 on the one side. So that's what I'm going to do, take 5 away from both sides. And then I'm going to try and solve it either by a quadratic formula or maybe by factoring if it factors easily enough. Well, this one, wouldn't you know it, it does factor quite easily. So I need x times x, and now I need 2 factors of positive 7 that add up to negative 8. So I'm thinking negative 7 and negative 1. So when I look at the solutions of this quadratic equation, I have 2 solutions. X could be 7 or it could be 1. So that would seem to be my solutions. But before you walk away and say, yeah, that was easy, there's one more thing you must do with these logarithmic equations. You have to go back and see if the 7 and the 1 are acceptable in the original, so this guy here, in the original form of the equation. In other words, if I plug this 7 in, then over here this would be a 7 take away 6, so this would be log of 1. That is acceptable because remember, the domain for logarithmic functions is that your x's have to be greater than 0. I guess it's a little misleading here. Whatever you take the log of, so I'll just write it up here, log x, okay, then whatever you take the log of, this expression here has to be greater than 0. So as long as this stays greater than 0, 7 minus 6, that's greater than 0. And 7 minus 2, that's greater than 0, so 7 works out just fine. But look at the 1. If I put a 1 in here, 1 minus 6, I'm trying to take the log of a negative 5. Well, that's not going to work, so I have to make sure to reject this guy. Okay, that looked like a good solution, but in fact, it doesn't work. So it has been rejected. So there's only the one solution, and that is x equals 7. All right, I have one more example to show you. And I'll just delete this page here. So in my second and final example of solving logarithmic equations, we have this. Log of x base 2 equals 2 plus 1/2 times log base 2 of x minus 3. All right, very similar to the previous one. I see I have a log base 2 on the left side, and I got a log base 2 with some other stuff happening on the right side. Why don't we bring those two logarithms together on the same side? So I'm going to subtract this logarithm here, and at the same time, I'm going to bring this 1/2 inside the logarithm, okay? And so it's going to look like this. Now, x minus 3 to the 1/2 is the same as the square root of x minus 3. Okay, all I've done is taken this 1/2 and said, oh, let's take that out and bring it in as an exponent. And then instead of writing it as a power, we'll write it as the square root of. And on the right side, I still have a 2. Now these I'm going to combine. We got the same bases, so I can combine them into one logarithm. But this time it's subtraction, so it's going to be division. So this is x divided by the square root of x minus 3, and that equals 2. And now I can go and write it as from the logarithmic form into the exponential form, which says 2 to the 2, so 2 squared, equals x divided by the square root of x minus 3. So now I've got to solve this equation. So here's what I'm going to do. I'm going to multiply both sides by the square root of x minus 3. What I want to do is get rid of the fraction. So if we can squeeze this in here. Okay, so what we're going to get on the left side of it all is 4 times the square root of x minus 3. And on the right side, these guys cancel, and I just got x. Now I want to get rid of this square root business, so I'm going to square both sides. Okay, in doing that, the 4 becomes a 16, and here I'm basically getting rid of the whole square root business. So that's kind of nice. And then over on this side, I got x squared. All right, let's put a little divider in here. We'll keep working up here. So now, what have I got? I've got 16x minus 48 equals x squared. And I can see, oh, that's a quadratic equation. Let's bring everything to the right side of it. So I have x squared minus 16x and plus 48, and I think this one actually factors. So let's see what we can do to solve it by factoring. So we would have x times x. Then I need a number times a number that makes positive 48 that adds up to negative 16. So I'm thinking negative 12 and negative 4. So it would seem we have two solutions, 12 and 4, and now what I'm going to do is go back to the original form and make sure I'm not doing anything strange. Now remember, I scribbled it out here, but originally we had a 1/2 here out in front, and this exponent wasn't there, so I just keep that in mind. Log of 12, that looks good, and here I would have log of 12 take away 3, and that's still a positive number, so 12 is good. That one checks out. How about 4? Log of 4 and log of 4 minus 3, or log of 1, yeah, that checks out too. So this time I have two solutions, and that's fine. And that's where I'm going to stop for now.